Hi, this is Mrs. Poland. This is the second video for lesson 6.04. We're on example 2. A Pew Internet American Life Project survey found that 392 of 7099 randomly selected teens reported texting with their friends every day. Part A. Calculate and interpret a 95% confidence interval for the population proportion P that would report texting with their friends every day. So let's do part A, and then I'll read part B. So it's the first 4-step process again. So step 1, we're going to state the parameter. So place your video on hold and state what you think the parameter is. P is the true proportion of all U.S. teens who report texting with their friends daily. Step 2. State the conditions. So put the video on hold and state what you think the 3 conditions are. Random selection as stated, so we have condition 1 verified. It is reasonable to assume that there are more than 7,990 teens in the U.S. Well, that's certainly true. And then the last condition is that success failure condition. And again, we have to use P hat as opposed to P since we don't know P. That's what we're trying to estimate. And so we know P hat is equal to 392 over 799. And you can either estimate that as a percentage, which turns out to be 0.491, or you can actually use the fraction. Either answer is fine. But you can see that both these conditions are verified. And again, the purpose of that third condition is to allow you to apply a normal model to your calculations. You must make a summary statement. In that summary statement, you must define which interval you're going to construct. So here's what I wrote. So since conditions have been met, we're constructing a 1 proportion z interval. That's the name of the interval. Remember, we're going to be going through a lot of different procedures, and you must identify the name of the procedure. So that's the purpose of that summary line. So that's like really key. You lose a point if you don't. Okay, we're now up to step 3. And in step 3, we are actually going to do the construction. So that's the calculations. So the general formula for a 1 proportion or any kind of confidence interval is the statistic or the point estimate plus or minus the margin of error. Specifically for 1 proportions, you're going to use P hat for the point estimate. To get the margin of error, it's the critical value times the standard error. So you need to know the general formula. I don't believe they give that to you on the new formula sheet. I do have to double check with that. But they do give you 100% the standard error of the confidence interval for 1 proportion, and that's square root of P hat Q hat over N. So again, you're using the hats because you don't know P, so you have no choice. So next step, they're asking for, in this problem, a 95% confidence level. So we have to get that value first. Some of you may end up memorizing it, which is fine, since that's a common one. But a lot of times on the AP exam, they ask for other values to test that you know how to get them. In actuality, we mainly use 95, 90, and 99 in real life, but you can use others. Okay, so this is 0.95. So if you're choosing a 95% confidence level, you're looking at the middle 95% of the distribution. And so alpha would be 1 minus 0.95 or 0.05. You're going to split that in half, and that's alpha over 2. So you're looking to get these critical values. To calculate the critical values, and again, this is how we represent it with a Z asterisk and then the 0.025 underneath. You don't have to actually write the 0.025, you just should know that's proper notation. You would do inverse norm, 0.025, 0,1. Put the video on hold and enter that into the calculator. You should have obtained 1.96. Okay, now for the rest of the construction, you must show me the substitution into the formula. So P hat, again, is equal to 392 over 799. So, and that's approximately 0.491. Carry it out to a minimum of 3 places. So that would be 0.491 plus or minus the critical value of 1.96. And now we're going to substitute in 0.491. 1 minus 0.491 is Q hat, and that turns out to be 0.508 over N, and N turns out to be 799. That's the sample size. So what I would expect on my tests and the homework assignments is I want to see the point estimate. I want to see that margin of error separately. So put the video on hold and enter that into the calculator. So you're going to enter 1.96 times control square root, control division, 0.491 times, I lost the point. Times 0.508 over 799, and you get 0.0346. And so for my calculations that I did earlier, I entered it as I rounded it to 0.035. Then you're going to get the lower limit, or the lower bound, and the upper bound. You actually don't need to show me this line that I'm working on. I'm just showing it now so people understand where it's coming from. 0.456 and 0.526. Tomorrow I'm going to show you an easier way to do the calculations, but for today's lesson, we're doing it the long way. And now we're on to our last and final step, and that's your conclusion. So the sentence frame you're going to use is, we are blank % confident that the interval from blank to blank captures the true proportion of, and you would fill in the blanks. So I'd like you to put the video on hold and fill in what you think the blanks are. We are 95% confident that the interval from 0.456 to 0.526 captures the true proportion of U.S. teens that text with their friends every day. Have a great day, everyone.